Humankind couldn't exist without water. It's also very important to know if water is any good before we use it. Team 3A Water wants to make analysis of water's metal concentrations faster and less expensive. Please welcome Tuomo Nissinen.
Thank you, Mikael and Maria. Good evening, everybody. What do you think? What is the actually most important resource? What are the most important things for the living? Sorry. Yeah. So you might think of air, you might think of water, maybe food, you might think even love. But I'm not here to talk about that. I think water is the most important resource in the world. And it is actually very essential for all the living and also for the industry. Pollution of the world's water resources is a huge problem, and it's caused by the industry and agriculture. Every time that we use water, it is really important to know what is the quality of it. Therefore, global water monitoring markets are actually huge, about $4 billion, and they are growing all the time. It is especially important to know what are the heavy metal contents of the waters that we use, because heavy metals can be deadly even at low concentrations. Problem with the heavy metals is that there is no real-time and on-site method for the analysis. Therefore, we need to use expensive and slow laboratory instrumentation for the analysis. So typically measurement goes like this. We go to the field, take a water sample, then deliver it to the laboratory, then prepare the sample, analyze it, and then we get the results. So there are various steps in the process, and it takes time and money. So it actually takes several days to weeks that we can get results from the measurements. And therefore, real-time data from the metal concentrations cannot be obtained ever. But we are going to change this. We have now developed cheap and precise method that can be used to analyze low metal concentrations from the water. It gives real-time results and can be performed on site. Our method is based on high technology nanomaterial that collects metals from the solutions. Because of this collection, we can use simpler, faster, and cheaper methods for the analysis. Our method could be utilized, for example, in these cases. So, safety monitoring of the drinking water. In developing countries, when there is often problems with the drinking water safety, there is no laboratory instrumentation there, and it's too expensive. But with our method, we can always ensure that the water is safe to drink on site. So we can go from well to well and check the water quality. Another good application is environmental monitoring. So if we can monitor better the emissions of the industry, we can also control the emissions better. So if there is, for example, leakage in the metal industry and metal-containing waters are leaking to the nature, with our real-time method, we can identify it and localize this leakage and react on that. And the leakage can be blocked even. And then the harm done to the nature by the heavy metal containing waters is reduced much. Industry is also very dependent on clean water. With our method, we can always verify that the water is clean enough before it enters to the process. We can also integrate the measurement system in automation so that we can optimize some processes even further that we know all the time what are the metal concentrations in the processes and then control the process better. So our team consists of scientists from the University of Eastern Finland. We have vast knowledge in nanomaterials and different analysis methods. We have also commercialization experts from Jyväskylä School of Business and Economics and advisory members from Geological Survey of Finland. So now we are looking for collaboration and partners to develop our method further, to find new possible applications for our technology, and find new pilot measurement opportunities. So I would be very pleased to discuss with you any water-related topics later on, so please contact. Thank you.